Hey guys, wanted to make a quick video about acceleration just to help out with some of the questions that are on 1.5 and in particular finding the average acceleration from a velocity time graph. So let's just go back. Let's think a little bit about what acceleration is. So in class we talked about this. The acceleration is going to be my change in velocity over the change in time. And this should look familiar. It should look a little bit like velocity, because velocity was going to be my change in position over the change in time. And just like on a position versus time graph, the slope of this position what gave me the velocity. So the slope equals velocity. So we're going to do the same thing, except now to get acceleration, it's going to be the slope on a velocity time graph. So when I look at the velocity in meters per second over time, the slope of the velocity graph is equal to the acceleration. So just thinking about that, I just want to talk about the units first, and then we'll actually find some. So if I find the acceleration from a velocity graph, let's look at the units. Sorry, that's change in velocity. So the change in velocity is going to be in meters per second. And we're going to divide that by time, which is in seconds. So if I multiply, I get meters over second times second, which is meters over second squared. So these are the units for acceleration. So let's go ahead and let's see if we can find some accelerations. So let's start with a simple one. So we'll just do the acceleration from A to B. So right along here. So this is a velocity versus time graph. So the slope of this will be my acceleration. So the acceleration from A to B would be the change in velocity over that time period. To find the change in velocity, we do the final minus the initial and divide that by the final time minus the initial time. So I'm going to skip this part in future ones, but you can just keep here. So my final velocity from A to B is going to be 20. And then I subtract the beginning velocity, which is 0. And then that's going to be over the change in time. So at B, my time was 2 seconds. So I have 2 minus, and time started at 0. So I get 20 over 2, which is 10 meters per second squared. That's my acceleration from A to B. From B to C, that should be pretty clear. That's 0 acceleration. So that's constant velocity. And then we could do this one, but let's go over here. Let's go from E to F. So my acceleration from E to F. And this is average acceleration. For these, since it's a constant velocity, my average is the same as my instantaneous, but we'll just call it average. So from E to F, I'll do my change in velocity over change in time. So going from E to F, I need to get my final velocity. So from here, I read over, and it's 20. So I get 20 minus my initial. So my initial was at E, which is 40. Over the change in time. So it goes 10 is my final, minus E is at 8. So I get negative 20 over 2. So I get negative 10 meters per second squared. So here we have 10 meters per second squared, negative 10. So on this one, from A to B, my velocity is increasing. So I can see that it's increasing. It's becoming more and more positive. Here, my velocity is decreasing. So I can see that my velocity is dropping down towards 0. Let's do another one. So just to get an average velocity, let's go from A to F. So I'm going to do this from A to F. It's not a very good line, but this would be, I would be finding my average velocity. This is how we would do it. Just like final velocity, We just care about where it started and where it ended. All this other stuff we don't really pay attention to. So my acceleration from A to F is going to be the change in velocity over time. So I find my final velocity, which is 20, minus my initial velocity, which is 0. My initial time is also going to be 0. And we divide that by the time, so that's 10 seconds. Minus 0, so I get 20 over 10, which is 2 meters per second squared. So my average velocity from here to here, even though my velocity jumped around a lot, the average velocity over this time period is just this slope of this line that connects the beginning and the end, which is 2 meters per second squared. So that should cover it.